Okay, so here we go. I forgot to start the recording, but somebody asked here on 65, so you can freeze it and take a look at it if you want. This has nothing to do with the problem. 15 is asked on 15 as well. So we're going to stick in this section today, but I do want to show you something that this next one, I'm not going to hold you responsible for on a test. Maybe be a great bonus. Okay? Because this is a very, very, very specific scenario. Yeah, I'm awesome at drawing straight lines. 4. Here we go. Let's take a look. So this one is something that, like I said, might be like bonus only. How in the heck would we solve something like this? This is nuts. This is, yeah.
Oh, you could find something that makes them, like you could find a power, like put them to the same number, like a power that equals to the same number. You do that?
But then my bases are different.
No, that's what I'm saying. Make your bases the same.
Oh, okay. In this one, since they're 4 and 3, I would love to do that. Like, say, if it was 4 and 2, I could go ahead and write them as powers of the same thing.
3 and 4 will never have the same power.
Nope. Nope. So this one, honestly, when I first started teaching out of this book, probably about 8 years ago, maybe 10 years ago, I saw this problem and I was like, honestly, I did not know what to do. I was like, it's a really rare situation. I was like, what the heck do I do? So here's what we're going to do. We're going to pick a base, either 4 or 3, and we're going to take the log of both sides. Okay? Which you want to pick, 3 or 4? 4, okay. So I'm going to take the log base 4 of this 4 raised to the 3x minus 1. And I'm going to take this one, log base 4 of 3 to the 2 minus x. Now, why didn't I do 4 over here and 3 over here? Because that would be illegal. I've got to do the same thing to both sides. Okay? Okay. So now, what happens to these two? They cancel out because the log base 4 and 4 raised to a power, they are inverse operations. And I just get 3x minus 1 equals log base 4 of 3 to the 2 minus x.
Could you move the 2 by 6 to the front?
Nice job.
Yeah, I know.
3x minus 1 equals 2 minus x times log base 4 of 3. Okay. So I'm going to stop right there for a second. This is just a number, right? It's some power. It's some number. It's going to be a little less than 1. But could we find what this number is?
Yeah.
By using the change of base, right? Okay. Let's go ahead. You know, in this problem, I'm going to go ahead and keep everything in terms of, hold on. Oh, they're doing this a little bit different than I would. But you're going to get the same thing. Hold on. Give me a second. The book's got a better idea. This would work, but the book's got a better idea. Okay. You know what? The book's method and my method are both really the same, but the book's method is actually going to be a little cleaner. Okay? Let's do the book's method. Okay? So. And I could show you how they're the same, but here's what we're going to do. We're going to take the log of both sides. And I'm just going to do the natural log because it's easy to write. What can I do with this 3x minus 1?
Move it to the front. Good job, Hunter. Thank you.
What can I do with this one?
Move it to the front.
Thanks, buddy.
No problem, Hunter. Thanks, guys.
Okay, it's just cleaner. It's just cleaner. Okay? So now, I've got to solve for x.
Raise them both to E.
Well, I can't quite do that because I've got some things that are... So the only thing I can do is this. I got to distribute 3x natural log of 4 minus natural log of 4. This kind of makes me want to throw up in my mouth a little bit.
Thought about throwing up in your mouth like you did.
What's wrong with you, Hunter?
Okay. Ugh. Everybody. Ugh. 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 Okay. But I think it's important for you guys to see some challenging things. So here's an x term. Here's an x term. I need to collect them all on one side. I need to collect them all on one side. So what I'm going to do is this. Exactly.
Oh, good job, Colby.
Colby's in fuego. You're on fire.
Yes.
Yes, okay. Now what?
I was just asking a question. Solve.
Well, but how do I solve?
Can you...
No, not yet. I got to take an x out.
So if you had this is probably no question. But if you had like an x natural log to the third on one side and an x natural log to the third on the other side, could you subtract all of it?
Yes.
Okay.
Mm-hmm. So now what?
Now you could.
Okay. There's two different things we could do here. This actually we could either just divide both sides, or what I could do, I'm going to have to change to a different sheet of paper. Check this out. See what I'm doing? Yeah. This is what happens when I don't have the time to prepare like I really wish I did. But that's not it's not an excuse, just a reason. But anyway,
If this is the bonus, Mr. Extra, I'm not even going to try.
I don't disagree.
If I just plug this in my calculator, wouldn't it get easier? Like just do X and then plug in.
Yeah. I'm just showing you. You'll kind of see. Do you see what I just did?
No.
Yes.
Oh, yeah, actually I do.
We just used the properties of logs, right?
Yes.
Yeah. So 3 becomes 4 to the third, plus becomes times, becomes a 9, that becomes a plus. So then I'm just going to do this all in one step. X equals the natural log of 36 divided by the natural log of, I think it's 192. 64 times 3, 2, 182. But, ugh. But yes, you could have divided both sides by this ugly thing. Yikes. Okay. So, again, will that be on a test?
Possibly. Bonus.
Maybe a bonus. Maybe a bonus. Maybe a bonus. Okay. Here we go. I'm going to do a couple from the section here. 70. I'm going to give you guys some problems that are similar to this today to kind of extend your abilities here a little bit. Log of 3x plus 2 plus 1 Now equals, God dang it. I should have just stayed home today.
Me too. I'm glad you came out with stretch right.
Okay.
How do you stop line?
Okay. What's 1? 1 is the log of what?
10 to the, or always 10 of 10.
Because if I want to combine these together, if that's a log, I need to rewrite this as a log. So log of 3x plus 2 equals log of 10 plus the log base 2 of x. You with me? Hear me barking? Log of 3x plus 2 equals the log of what? Help me out. Show me you remember something from last week. 10 times 2x, so 20x. So then what can I write?
3x plus 2 equals 20x. Good job. Good job. Subtract 3x and 2x is 217.
Okay, so I'm going to give you a couple of problems today where you have to go from a number, use your knowledge of logs, and replace that with a log so you can combine it with other logs. Okay, so I'm going to ask you guys to try one on your own. Log of 50x equals 2 plus the log of 2x minus 3. Try it.
I know that. I'm trying log base what for the 2?
It's at base 10 because it's common log.
Oh, sorry.
Sam, you get it already? Or are you stuck? What'd you get? Get it?
I got stuck.
But you got this part, right?
Yep, I got that.
So you use the laws of logs.
Oh, I got it. What'd you get? Is it this much? Yeah. Oh yeah, you can get it. This is where I just forgot you can get the logs. I was trying to figure out how to do it. They just leave.
Okay.
Questions, Record. Would you be able to, like, I'm just thinking, if you moved it up on, oh, never mind. It's not multiple. I was thinking if you move it up on top and then boil it out, but I just remember that being multiplied by that.
Why are the logs just like able to be just because they just subtract them?
Well, this one, I skipped a step.
Oh, you did. Okay. Yeah.
Okay. Let's do a scary looking one. You ready?
Yes, sir.
I don't want you scared.
Oh, we got to do the dead person one too. Let's do the dead person one. This is a great problem. Okay. Forensic pathologists perform autopsies to determine the time and cause of death. I don't know. I just think this is fascinating. The time t in hours since death can be calculated by t is equal to -10 natural log of t minus r1 over 98.6 minus r1. Okay. And r1 is the room temperature.
Isn't it RT? Is that or is it the same thing? I think it's RT.
Oh, it's a T? Oh, it is a T, isn't it? That makes much more sense. Okay, so here's the thing. Do you think that from a corpse's body temperature that you should be able to go back and figure out how long they've been dead for?
Yes.
Yeah. Assuming that it hasn't been like 30 days. I'm talking their body temperature is still different than room temperature. If the room's 70 degrees and the body's 70 degrees, it could have been a long time. But if the room's 70 degrees and the body is 80 degrees, well, then that's a function of time. Because they're going to equalize at a certain rate, okay? And T is the temperature of the body, okay? A forensic pathologist measures the body temperature to be 93 degrees in a room that is 72 degrees Fahrenheit. What is the time of death? Okay. So -10 natural log 93 minus 72. I just think this is a very interesting problem. Okay? So what you have is you've got a ratio of comparing, this formula would be given to you on a test of some sort. Yeah. Because this is actually not a terribly difficult problem.
It should be 21 over 26.6.
Yep, which would be what? Give me a decimal. I'd like a couple people to calculate this out for me. Make sure we're getting the right thing. .789 what? 47. That's good. Is that right? You guys agree with that? Okay. Oh, this is just a calculator problem. There's no solving anymore at all.
Nice.
Because my variable is already by itself. My base is E.
Sorry, just put the whole thing in?
2.36 hours.
Yep. Okay. That was not too bad. That's just getting us used to the formula. Got it? Okay. Let's try a different scenario. Let's say I've got this situation. Hospital patient passed away 4 hours ago. Okay, so T equals 4. If the hospital has an average temperature of 75 degrees, so RT equals 75. Find the temperature of the body. Well, let's figure this one out. Same equation. 4 equals -10 natural log t minus 75 over 98.6 minus 75.
Times by 23.6 on both sides.
No, because that's inside a log.
Oh, yeah.
That's inside a log. So we can't just peel out of that. Okay. So we're all there. Now what? I've got to get rid of this. How do I get rid of that?
Raise it to E.
Well, this is a base of E.
Oh, shoot.
So now I just got to interpret what it means. What to the what equals what? Yeah, e to the negative 0.4 is equal to t minus 75 over 23.6. So that's just shifting gears. It's going from logarithmic form to exponential form. And let's go ahead, e to the negative 0.4. 0.67, give me more. 0.320. 0.3, okay? And I'm assuming you guys could solve that from there in your sleep, basically?
P minus 75 equals
Hey, we can solve that in our sleep, right, guys?
82.
What?
90.82.
90.82.
Yes, my savior too.
No.
I talked about my 6-year-old sister like that.
Yeah, she's
Okay. Got one more I want you to do. Based upon the same scenario. So we're going to use the same formula, so I'm just going to use this. So let's do part C now. The temperature is 89 degrees 3.5 hours later. So after death. Find room temperature. Go, get started. Too many T's.
What's the first T stand for?
T equals is time in hours.
It's time. Okay. Okay. Are we still using the 9.81 or 98.6?
Yes. Yep. Yeah, because that's your original value of the body temperature. We're assuming.
Okay.
So what we're going to do here is
Whoa.
no solution.
No. This one's the hardest of the three. I will unfreeze what I've got so far.
Oh, I'm exactly with you.
Good.
I got to Oh, it just has. Oh. We get stuck on the easiest steps.
Cross multiply.
I think I got it.
What'd you get?
66.102.
Nice job. Okay, rather than just say, nice job and move on, what you've got to do is you've just got to think about, plug in your original, simplify if you can, and now on this step, I've got to change gears. I've got to get rid of the log, replace with a decimal, and then you can cross multiply pretty nicely.
Wait, Eddie, what'd you get?
66 degrees.
Oh. You get 0.066. No. I got 11.
Okay, let's find out where you went wrong. Okay, up here, Gigi. Are you to this point right here?
Yep.
Okay, so you got this then, right?
Yep.
So then you replace this with a decimal?
Yep.
Okay, so now what I did here is I took 0.705 times everything here. Equals 89 minus R.
Okay. There's that. So I got the 89 minus, I put x instead of r. I put 89 minus x equals 69.5138 minus 0.705x.
Minus what? 0 point what?
705.
Okay, got it. Good.
And then what I did was I added the x from 89 minus x over.
So did I.
So then it got me to 89 equals 69.5 plus 1.7.
No, this is negative. So you're going to cancel. So that's what I did. I added R to both sides. So negative 0.705 plus 1. You're going to get...
Oh, I see.
Okay. Okay. Last one. $27 equals 12 over 1 minus 1/2 e to the negative x. Okay, we'll do this one together. What do you want to do?
So change the 1 to a log of 10. Or a natural log.
No,
No.
because I don't have any other logs I want to combine it with. That's the only reason I did it on that previous one. Here's my hint to you. Cross multiply. So you get 12 equals 27 minus 13.5. I'll go ahead and do it that way then. Okay. Yeah, I can't. This has an e to the x, so I got to leave that alone. So let's get rid of that. Subtract 27, which I know I'm being patient. Now what? Yeah, divide by my negative 13.5.
You get 1.1 repeating.
Okay. Oh, not x equals e to the negative x.
Then you raise them both to the natural log.
Yeah, I could go ahead and take the natural log of both sides if I wanted to. But here's what I'm going to do. Oh yeah, I'll just do it this way.
Yeah. So negative 0.095.
Hmm.
Yeah, it's like, what do you get? Yeah, negative 0.095. Okay.
Really?
Yeah.
Okay, we don't agree with the book, so we've got an issue.
What does the book get?
Negative 0.11. You got it?
Negative 1.11?
No, 0.11.
What did you get?
Okay, so here's the issue. If you just type in 1.1, you're going to get something different. I typed in 1.1111111111111. Okay? So my x is approximately negative 0.105.
Oh, yeah, I got that.
Good. So here's what we're going to do. I just wanted to throw in just a couple things that would make you go, woo! So Monday.
Oh, yeah.
So I'm going to throw in just some randos here and there, just to kind of, do a little summarize here from everything. Let's go page 196, 7.
Oh, looks like I only get one problem.
What? Oh, I'm that far off? I'm sorry. Okay, hold on. Yes.
See tomorrow,
Let's go 73, 77, and 103. Sorry, I was thinking we got out a little bit later. That's why my timing was messed up. That was not good.